Okay, so now what we're going to do is we're going to go into calculating the number of moles and concentrations of the solutions that we're going to need for figuring out some of these results. So to do that, let's take a look at what the solutions were. So remember, we made solution A, which was bromocresol green in sodium acetate. So it should be basic. Acetate's a basic ion. Then we made an acetic acid solution, and then you made a blank solution. Okay, so we're going to do calculations for solution A and B. So let's take a look here. For solution A, the first thing we need is the molarity of the sodium acetate solution that's on the bottle. Okay, so we're going to add, that's bromocresol, 5 milliliters of 0.200 molar sodium acetate, right? So 0.2 molar. Okay, the next thing it says, let's put an extra sig fitting in there. There we go. The next thing it says is what volume did we use to do that? Well, it's 5 milliliters. We put in 5 milliliters. And then let's convert that into liters. So how do you convert 5 milliliters into liters? You divide by 1,000. So equal sign, this cell over 1,000. Okay, you don't need to autofill there. And then the moles of sodium acetate solution that were used in this solution. So now what we're doing is we're calculating the number of moles that are in the graduated cylinder. And we can say the moles is equal to molarity times volume. So equal molarity times volume. Remember, the volume needs to be in liters. Okay, so that's the number of moles of sodium acetate that were used in that dilution. Now we can move on to solution B. That's the acetic acid solution. So the first thing is, what's the molarity of the acetic acid solution in the bottle? Well, let's come over here. Here we go, B. We're going to use 25.0 milliliters of 1 molar acetic acid, and then we'll dilute it to a total of 100 milliliters. Okay. All right, so our molarity is 1.00. The volume that we used was 25.0. We're going to convert milliliters into liters here. So equal sign 25 divided by 1,000. Okay, let's give it a little bit more sig figs here. And then the next thing we do is moles of acetic acid used in the dilution. So moles is molarity times volume in liters. So equal sign molarity times volume in liters. Okay. So 0.025 moles. So notice there's a lot more moles of acetic acid that we've made that solution than there was the sodium acetate. The next thing is, what was the total volume? Well, let's go back. For solution B, we added water and went to a total of 100 milliliters. So 100.0. Okay. Again, let's add an extra sig fig there. And then now, what is that total volume in liters? So the first is in liters. So equal sign volume in milliliters divided by 1,000. Okay, so we got that so far. That's looking good. Now, there's one little error here. So let me see if I can grab this. And we'll put it there. Okay, let me just make this cell a little bit bigger. And we'll make the text a little bit larger. And then I'm going to have to wrap it. So data format wrap. Okay, so let me just wrap that a little bit so that we can make it fit in a smaller space. And then over here, let's go ahead and put in, there we go, a little bit of cell there. Okay, so the molarity of the acetic acid in the diluted solution. Okay, so what's the molarity of the diluted solution? Well, you take the number, molarity is moles over volume. So the number of moles we had was right here, 0.025. So this one, and then we're going to divide that by the volume in liters, which is 0.1. Okay, that's pretty small, so let's make it a little bit bigger. Come up there, put that in the middle, and then we can make this cell a little bit, the number a little bit larger. Okay, so you got your two concentrations. Or I should say we've got the number of moles of sodium acetate, and now we have the molarity of the acetic acid solution for those tables.